Hi, my name is Nimisha. I work as a software engineer at Confluent, and I'm here together with my colleague Alvaro. We are here to share a little about how Confluent migrated to use Cilium on our multi-cloud fleet of Kubernetes clusters. Confluent Cloud is a cloud-based data streaming platform that provides managed services such as Kafka and Flink to help companies process and connect data. It is available on AWS, Azure, and Google Cloud, consisting of applications deployed on thousands of Kubernetes clusters across many regions. We use the cloud provider's managed Kubernetes services, with the default CNIs managing networking in the clusters. We chose to migrate to Cilium for its security features such as transparent encryption, DNS-based network policies, and enhanced observability with Hubble. Another motivation was maintaining a consistent CNI across our fleet and not having to deal with cloud provider-specific behaviors. Additionally, having support from Isovalent for our enterprise Cilium installation made the decision to migrate much easier. There are risks associated with replacing a low-level component like the CNI. The main challenge was doing a live migration on clusters running production workloads without any network disruption or loss of connectivity in the clusters.
So let's talk a bit about the actual migration process, starting with AWS. The way we do this is to set up Cilium only on new nodes while leaving the old one managed by the default AWS CNI. To achieve this, we label new nodes with the CNI equals Cilium label. We then configure the default AWS CNI to have a node selector that does not match this label, and then we install Cilium with node selector that only matches it. Then we bring up new nodes, and because of these selectors, only the new Cilium CNI pods will run on them. The two CNIs can coexist in the same Kubernetes cluster because at the end of the day, they both use AWS native routing. So workloads can communicate with each other regardless of which of the two CNIs is being used. So once the new nodes are up, we clean up the existing ones so all workloads get moved over to Cilium managed nodes. And then once that is done, we delete all nodes with the AWS CNI on them. And once they are all gone, we just delete the AWS CNI altogether from the cluster.
For CNI migration on GCP clusters, we followed more or less the same process of bringing up new nodes with Cilium and migrating workloads onto them. However, the default CNI with GKE called netd is enabled by default when using certain features. A gotcha here is that since netd cannot be uninstalled, a node could become ready even before Cilium has finished configuring it, which means application pods can get scheduled on the node before the Cilium agent. As a result, this can leave some pods unmanaged by Cilium and can lead to multiple pods ending up with the same IP address. On Azure, there is an officially supported migration path as shown here. However, the migration is quite complex and involves transitioning through various CNI configurations, during which nodes have to be replaced multiple times as well. Another important caveat worth mentioning is that with this migration path, you always end up with Cilium using overlay routing instead of native routing. Because this migration path is a little involved and long-running, we did not end up implementing it at Confluent and only install Cilium on new Azure clusters for now.
So to summarize a bit what we've learned, no matter how much testing there is, some issues will realistically only surface in production, like the IP clashes we've seen on GCP. Generally, if you're running a multi-cloud setup, the Cilium configuration will likely not be completely identical across all of them. Versioning it and using GitHub helps a lot with keeping it consistent where possible and being able to pinpoint issues to changes. The integrated unmanaged pod watcher helps with finding unmanaged pods, but unfortunately does pod deletions and not evictions, and as a result will not respect pod disruption budgets. It also pretty much doesn't work in the context of a migration because existing nodes in such a migration by design have no Cilium on them. And we don't want it to just delete everything on these existing old nodes without Cilium and cause a downtime. So basically it cannot be used. An alternate to this is to just monitor pods that are unmanaged by Cilium on nodes that do have Cilium in them, and then alert on them while this migration is ongoing. As always, when finding issues like this, document them for the rest of the team and try to leverage the open source community as much as possible.